So this is experiment number 2, the quantitative spectrometric determination of copper. So we're going to use a commercial system and we're going to compare the results from that to a homemade system that we're going to build using some optical mechanical components that I have here on the bench for you. What you'll basically do is you'll follow the method, prepare your series of copper standards, and once you have them made up, you'll then measure them on the commercial system and then straight away on the homemade system, and then do the next standard and the next standard. And then you'll analyse an unknown sample and you'll calculate the LODs and LOQs for both calibrations and compare the two systems together. So I'll run through how to actually build the colorimeter now with the components that we have here on the bench, and I'll then also show you how to use the commercial system as well. So when you come in, you'll find a range of components. Now they'll actually be in a brown box over there, but you'll have some optical rods, some blank plates, a cube, a cuvette holder, a lid, just a normal phone charger, a post, an M6 nut, a base plate, a USB charger for the LED. You have a detector here with this connector on the back of it, and this is your LED here, somewhat similar to what you'll find in a remote control. You also have a couple of blanking flanges here that we're actually going to put in. So we're actually going to run through how you construct the instrument now based on all of these components. So I'll show you that now. Okay, so the first thing that we're going to have is this cube system here, and these are all made by a crowd called Tor Labs. You can make various optical configurations. This is a bit like really advanced Lego. So take the cube, and the first thing you want to do is take the cuvette holder and place it into the cube. Now you'll notice on the cube that on one side there's 4 clear through holes. So I want you to mount the cuvette holder that has these kind of like bars here for the poles to go through. I want you to align them up with the poles and that, and just kind of center it as much as you can. It should kind of click into place. There we go. So it'll sit in like that. Okay, so that's the first thing you do. The next thing you're going to do is thread 4 of these guys through those holes. So you just push them in through the front and it'll go straight through the back. Place it so it's about 1 centimeter. This, you want one end slightly longer than the other. And then put in the rest of the poles as well. They should just slide in nice and easily. Shouldn't require too much force. It'll require a little bit, but not a whole lot. So there you go. That's the first part done. So I've got the 4 poles pushed through. My cuvette holder is now nice and rigid. It's not going anywhere. The next thing I want you to do is to put on the 2 side blanking flanges and put them onto these sides here. So these just screw on. That's one. And onto the other side, directly opposite that guy, on this one, screw him on as well. That's just going to make sure that the colorimeter is light proof, that there's no light getting in and around from external sources. It's just going to help improve the sensitivity. So screw it on. It can be a bit tricky to get that right. So you'll end up with the 2 blanks on either side of the cube. The next thing that we're going to do is we're going to place on my holder for my light, my LED light source. This LED emits at one particular wavelength. Copper sulfate absorbs up around 810 nanometers. It's got a broad absorption up in that region. This emits at 810 nanometers, so it matches the absorption band. So the emission profile of this matches the absorption band of the copper sulfate. So what I want you to do is literally take your cube and just slide that onto the end of it, like so. Okay? So it'll sit like that. Now, what I want you to do now is to take one of the Allen keys that are given to you, and there's grub screws here on the side of it. Just screw it in so it catches it. Don't over tighten these, you don't need to. And screw in the 4 grub screws. So you can see them there. They're on the actual plate itself. You could also screw in the posts on the actual cube as well. So do that too. Just screw them in lightly. And that'll just stop the rods from slipping out. And do the other side as well. So it's relatively quick. But the advantage of this, in previous years I would have got students to make this out of Lego. It works, it's fine. but this is just a little bit more accurate. Okay, so now I've got my cube, I've got my light source installed, I've got my cuvette holder ready, and I've got 4 poles sitting out. The next thing to do is to take one of these. Take one of these plastic 3D printed inserts. We're going to just slide it over the end on that end. Okay, I'm not sure if you can see that. You can just see I've slid it in. Put the other 3 on. So put the other ones on as well. So now I should have the blanks all the way around here. Then what I want to do is take the detector, which is just a silicon photodiode. It's just like your solar cells that you get for a calculator. It's just a little bit of silicon straight in the center there, a little black thing. Just slide that in on top. Now when you're attaching this, okay, I want you to attach it that it's got the hole here that you can see in the video that's pointing downwards, because that's going to be the mount that I'm going to actually use to hold the whole system up. Okay, so it slips on, but on the bottom side of it, what you'll actually see is that there's a little hole here, and that hole is for this post to screw into. So just screw that post into it. Use the Allen key that you've got just to tighten it a wee bit, just twist it, finger tight, and then just tighten up the grub screws that actually hold the detector in place. And we're good to go, and we're good to go there. So now I've all that ready. The next thing to do is to take your base plate, which is here, and I'm just going to place this to one side for a second, and mount the post holder, this thing here, onto the base plate. Okay, again, this is an aluminium base plate. It's nice and rigid, gives some real strength to the system. So take an M6 bolt and just somewhere in the middle, just screw that into place using the larger Allen key that you've been given. Don't over tighten these. Really, we should have washers on these, but it'll be fine. But what you'll end up with is that. Okay, it's just a mounted plate. For us, it's perfect. Take the holder that you just made and slot that into here. Now this can be difficult to see because everything's black. It's optical equipment, so generally we use black. And then just tighten this bolt down here at the bottom. Okay, using the M6 as well. Okay, so that's rock solid now. That's not going anywhere. That's perfect. The next thing to do is to connect this BNC connector, okay, onto the end of the detector. Push it in and twist it. Okay, so to undo it, twist it and pull it out. Put it on, push it in, and then twist the BNC connector, and that should hold it in place. Take the 2 banana plugs at the end and plug the black one into the COM port at the very, very bottom, and plug the red one into the voltage reader here. Rotate the dial until it's reading at the 2000s M position, so that position there. And you'll see it's reading a value at the minute of 0 volts because there's no light getting to it. The next thing I want you to do is to take this USB cable and unwind it. And once you've got it unwound, I want you to plug it in to that USB slot there. Now be careful, this is one of the old-fashioned USBs, so don't put it in the wrong way. It's not a USB-C. So looking at it, it's really hard to tell. So it's pointing down. Push it in there and it should click in, be fine. And onto the other end of that cable, plug in a USB charger. This is just a phone charger, no Nokia or something like that, no, Huawei. So take this and plug it into the wall, turn it on. And what's happening now is that it's actually emitting light. You can't see it because it's just near the infrared. You might be able to see it now, just a tiny little red glow just there. Our eyes aren't really sensitive up in that wavelength range, so it doesn't look very bright, but realistically, it's incredibly bright because it's generating 460 milliwatts of power. All right, so that's like half a volt has been generated from that. And the other thing that you'll notice about this is it's really stable. It's not shifting. All right. There's one last thing I want you to do is I want you to place the cover on top, and that will stop any stray light from getting in. So once you've made up your standards, what you're going to do is you're going to measure them on this instrument. Now, to measure any sample on this system, what you've got to do is rotate that dial until that reads 800, whatever wavelength you're interested in. For us, it's 810 nanometers. Open up the lid, take out the cuvette holder, close the lid, push the mode button over here until it's in transmittance. If that's not at 0, press the 0% adjust. So just press 0% adjust. Lift up the lid, take your blank solution, and we're going to use these plastic cuvettes today for our analysis. Okay, so what I'm going to do is I'm actually going to fill that with some water, just deionized water. Slip it into the holder. These have 2 frosted faces and 2 clear. Make sure you have the clear faces pointing in the right direction. Okay, so the clear face should be visible through here. Take that, and with the sloped side, put it in this direction. The slope side should face the arrow. Slide it in, close the lid, and when you see this number here, press 100% adjust. Then press the mode button to change it into absorbance values. So that's the absorbance now of my blank. I'm going to take that, bring it out. I'm actually going to then place it straight into my colorimeter, put the lid back on, and that's my blank voltage, 463 millivolts. So that's the amount of light associated with the blank. You're to write that number down. Right. Once you've done that, start with your lowest standard. Now I've just got a copper solution here. I don't know what it is. I just made it up. You're going to have your exact standards, and you start with the low and you work high. So what I'm going to do is I'm just going to pour in my sample in here. I'm going to place it in the holder, making sure I've got the clear sides pointing in the right direction. It can be tricky on these, but make sure the clear sides are pointing at the front window. Put it in. There, close that. Put your sample in. Close the lid. And I'm reading a value of 1.192 absorbance units. Important to remember, absorbance doesn't have a unit. Okay, it's a ratio, so it doesn't have a unit. So that's what we measure on the commercial system for our standard, right? Your values will be lower, they'll go up higher. So it then once I've measured it on this, I take it straight out, and then I measure it on this, making sure I keep the clear face pointing in that direction. And what you'll notice is that the value is now dropped to 344, 343 volts. So I've had a reduction in the voltage that's reaching my detector. And on the sheet that I've given you, there's a formula here for calculating the percent transmittance and then converting it into the equivalent absorbance that you then can compare to this system. Okay, so what I want you to do is run all your standards, do them in duplicate on both systems, hop them up and down just like I've been demonstrating it there. Once you've done that, then analyze your sample in triplicate. All right, so you'll have 3 values, take the average of that, and that's the one that you'll then use for determining the concentration of the unknown. Determine the LODs and the LOQs for both systems. When you're finished, really, really important, turn off the power of this multimeter here. Just put it into the off position. Take out any cuvettes that may be present, okay, in the sample holder, all right? And disassemble the instrument. So again, just unplug it, close the lid, switch off the light source, unplug this, take this off, and it's relatively quick. It shouldn't take you that long as I knock everything on the bench. And I'm just going to demonstrate taking it apart. And what I would like you to do at the very, very end is when you are finished with all the components, place them all back into this brown box for the next group to come in. So that's all you got to do, guys. All right. Any problems, give me a shout.